It's the team project for Engineering and Technology 4375, the fall of 2018, which is facility planning. And our team members are myself, Zachary Barton, Bridger Clark, and Robert Goll. Currently, the straight line configuration of this production line takes up a footprint of 42 feet by 6 feet. So the total footprint is 252 feet squared. And as you can see through our chart, that there's large idle times for workers, for all the workers, with the highest idle times occurring at worker 1 and worker 7. So with this current configuration, there's several drawbacks, because there's a 1 worker for every process, which creates 7 workstations, because each workstation feeds into the adjacent one with a worker stationed at each one. Which this creates the bottlenecks at process 2 and 6 for product A, because process 2 gets fed at a high rate from process 1, and then as soon as process 3 draws from process 2, he's able to get a job, but then he sits idle for 3/4 of an hour after every job that he finishes. Process 4 is once again getting fed straight from process 3 as soon as he gets done, but then product is still going to back up in process 4. Process 5 draws straight from process 4 in product A, and then in process 6, once again, he's outpacing his work times, so therefore there's going to be a lot of product backing up in process 6. And then process 7 draws straight from process 6 as soon as he gets done, but there's 2 hours of idle time in between every time that process 6 is finished to process 7. And then for product B, there's going to be bottlenecks at process 2, 4, and 6. And it's kind of the same scenario where process 1 feeds straight into process 2, and as soon as he receives a job, he can start working on it, but process B is going to start piling up because he can't keep up with his workload. And then as it feeds into process 3 and process 4, there's going to be another bottleneck at process 4, because process 3 draws straight from process 2, and then he's going to start backing up because once again he can't keep up with his work process times. And then the same thing, once it gets to process 6, there's going to be another bottleneck because he's backing up to his outpaced production. So once again, this is the uneven processing times creates large idle times for the workers, which is highly inefficient, and that's what we're looking to solve through this change into a U-cell format. And what this creates, because of all these bottlenecks and uneven process times, is a large work in process, because the workers can't, the following workers can't keep up with the preceding workers, and therefore the product's going to pile up, and then at the end of the day, you've got this large number of products that have gone through process 5, but process 6, it's still waiting on process 6, and so it just creates a lot of work in progress every day. So the justification for the U-shaped cell layout is that there's going to be lower fatigue for workers due to the greater variety in their jobs, and there's going to be lower production costs due to the lower manpower requirements, and it's going to be an elimination of production bottlenecks because the processing times are going to be equalized, and therefore there's going to be an elimination of worker idle time as well, because as soon as the one worker gets done with the product, it's going to go to the next worker, and since their times are matched up, there's not going to be any waiting on the second operator's part, and there's not going to be any backup of parts because the previous worker outpaces his work, because all the work's going to be equalized, and therefore there's going to be a greater flexibility in production also, because you're not going to at the end of the day end up with all these unprocessed parts. They're going to be more in sync every time that you finish one product. It's going to go to the next process, and then from that process it's going to go to the next one and be, they're all going to end up being done at the same time. And this is going to create greater worker utilization and flexibility, because we're going to have workers learning several processes, because we're eliminating workers. We're going to eliminate down to 3 workers, so therefore those 3 workers have to handle the processes that several workers used to handle. So even though their workload increases as far as the amount of processes they have to do, their times are going to be synced up. So that creates the flexibility from learning to perform several processes. And this is going to create a lower working process, like I talked about before, because everything's going to be more synced up. And this is going to create a greater utilization of shop space due to the smaller footprint of the production line, which we'll talk about in a minute. And this is going to be a reduction in production process times for both products. Product A is going to go down to each worker is going to have a 3-hour process time, compared to previously they all had mixed process times, and the whole product progress time was 9 hours. And then product B is going to go down to 1.5 hours for each worker to finish their processes, and compared to the total processing time currently is 4.5 hours for product B. And then I'm going to leave it to my next associate, Bridger Clark, to explain the next few slides. Thank you.
Before committing to the U-shaped cell, we wanted to validate the benefits. The validation was confirmed by using current build rates per product and ensuring we could replicate, if not improve. What we found was that in the U-shaped format, we could produce the current rate with 2.53 workers. When staffing our design with 3 workers, the capacity was increased by 18.5%. The image on the left shows our production flow amongst the workstations. As shown, workstation 1 performs processes 1, 2, and 3 of both product A and B. Workstation 2 performs processes 4 and 5 of product A and process 4 of product B. Workstation 3 completes both products, housing processes 6 and 7 of product A and 5, 6, and 7 of B. As you can see, they all have balanced cycle times, which is one of the benefits that we see from that. Some of the other benefits include a smaller footprint, around 90 square foot smaller than the old line, less handling of the products from station to station, lower reject repair rate, lowered WIP, no waiting for processes because we have balanced workflow, greater utilization of the workforce. 1 worker is assigned to each workstation, and each workstation performs several processes, and they're all determined by what product is coming through the station, which increases our efficiency.
So here we have our production schedule broken out by workers and what processes they're going to work. For worker 1, we have them working process 1, 2, and 3 for product A. Worker 2 covers process 4 and 5, and worker 3 covers process 6 and 7. For product B, worker 1 covers processes 1, 2, and 3 again, but worker 2 only covers process 4. Worker 3 will cover 5, 6, and 7. This meets our goal of 22 units of product A and 55 units of product B, working 148 hours out of the month. Our productivity increases by 18% as mentioned earlier, giving us an extra 4 units of product A and 10 units of product B. Changing to the U-shaped cell allows us increased line efficiency, increased production, increased profits, and lowers our overhead by moving from 7 workstations in the old linear shape to the 3 workstations in the current U-shape. We also decrease our footprint by over 100 square feet. The old linear shape isn't working for us. It doesn't meet our needs. It doesn't allow us the growth that we're looking for. By moving to this U-shape, we're taking a step forward to meet the goals that we need to meet to be a productive business. I hope you consider the U-shaped cell as a possibility for your new layout, and I hope you recognize all the benefits that it has. Thank you.